everyone. In this module, I'll be going over surveying equipment and discuss surveying techniques. All the information provided in this module will be gone over during our hands-on training that's going to take place at a later time. I'm sure during that training, some of this information will make a lot more sense. But before we can do that, I'm going to go over everything in this PowerPoint. So the first piece of equipment we will use to monitor radiation is the LEDM 3 survey meter. You all will more than likely not be using these meters unless you end up working at a shelter or a worker decon site. More than likely, you will be using a CDV 718A meter, which we will go over here later in the module. Anyway, the LEDMs are an easy way to monitor for radiation contamination. In order to use a LEDM, you must first put the monitor together. This will be a lot easier to understand once we have our hands-on training, but I'm going to try to walk you through the process step by step. To begin, make sure that the range selector switch is in the off position. The range selector switch is conveniently located right under that handle. When the switch is turned off, connect the probe, pancake probe is what you're going to use, to the monitor with the connecting cable. When connecting the cable, make sure the cable is locked in place before you use it. You can check this by pulling on the cable to ensure that it does not come loose. If the cable is loose, twist the cable connections to lock them in place. Next, open the battery lid. Again, this is located underneath the handle. Do not open the latches on the ends of the monitors. The battery slot is always going to be located under the handle and will have a silver twist knob. You will then install the batteries. Make sure to match the batteries with the plus and minus symbols located on the battery lid inside the lid. Then close the lid and turn the knob to make sure it is locked. Once you have done this, change the range switch to BAT. This is the battery test function. When the knob is in this position, the needle on the scale should move all the way to the right and fall somewhere between that BAT test range. If the batteries are bad, go ahead and change them out. If they are good, remove the protective cover on the pancake probe. And then you will want to make sure that the AUD, which is the audio, make sure that switch is set on, and the FS switch is set to fast, which is the F. To begin the operability test, return the range selector switch to times 100. So to do the operability check, you will need to open the check source door on the side of the monitor. This is that little yellow door on the side. There's a small radioactive source behind the door that you can use to ensure that the monitor is working correctly. So after you open that door, place the mesh side of the probe against the source. The monitor should begin to chirp rapidly. Next, you will need to change that range selector switch to times 10 and place the probe back over that check source. The meter should read somewhere between that plus or minus 20% of the reading indicated on the calibration label that's on the side of your monitor. It should be next to that radiological source door. If the monitor is working correctly and is calibrated into the correct range, you can close the check source door, press the reset button, and then turn the range selector switch to times 0.1. At this point, your LEDM 3 monitor is ready to use. Okay, so knowing how to read the LEDM monitor scale correctly is probably the most difficult part of using this monitor. The first thing to know is that the LEDM measures in counts per minute, or CPM for short. The scale on the meter is between 0K and 5K, as you can see. So 5 is going to be 5,000. Each tick mark is 100. So when monitoring, you will have to do some math depending on where the range selector switch is set. So take, for example, the needle is on 3K. If that's true, then if the switch is on times 0.1, then the actual reading is going to be 300 counts per minute. If the range selector switch is on times 1, the reading will be on 3,000. For times 10, it's going to be 30,000, times 100, 300,000. Now to the CDV 718A survey meter. This is the piece of equipment you will be using. I'll go over how to set it up in the next few slides. In each meter case, there will be a step-by-step instructions on how to set up and use these meters. So if you forget, just use those instructions as a guide. Again, being able to do this in the hands-on training later will make more sense, but this next few slides will give you a general idea on how to set it up and use the meter. So to get your 718 into operation, you must first make sure the power switch is off and the alarm switch is switched to chirp. This is so you can hear when the meter is actually going off. Then you will loosen the screws on the battery cap on the back of the meter. Next, you will connect the probe. In most cases, you'll be using the pancake probe, which will detect alpha, beta, and gamma radiation. Proceed by removing the battery cover and then inserting the 3 batteries properly. There is a small picture on the inside of the battery well that shows which way the batteries should go. All 3 batteries will be inserted the same way. You're then going to replace the cover and tighten the screws. You're going to then set the power to on, which is the up position. If for some reason there is a flashing 8 on the screen, press the CLR/test button. Then wait for digits and arrows to be displayed. The arrows will indicate the type of probe and reading displayed. 2 arrows are going to be used for beta and gamma probe, and 1 for the pancake probe, which is what you will be using in most cases. When using the pancake probe, the reading will always be in counts per minute or CPM. To continue, press and hold the CLR/test button until the alarm sounds. When the display shows 3 8s and 3 arrows, you will need to perform the next few steps quickly. You will need to set the alarm to VIS, which is the center position, and the alarm will stop. Set alarm to audio vis, which is the down position, and trend lights will come on. Next, set alarm to chirp, which is the up position, and the alarm will go off again. When you have completed those steps, the digit/unit test will begin with 3 zeros. When the test begins, it will go through the sequence listed on the screen. This can sometimes go very quickly, so you don't need to be alarmed if you don't see every number appear. The electrical test will begin immediately following the 999K display. If you see some 1-digit codes on the screen at this time, just go ahead and ignore them. So if the test went well, a flashing 9 will appear with the pulsing alarm. When you see the 9, you can move to step 16. But if something goes wrong and there's a flashing 0 that appears, turn the unit off and repeat steps 7 through 14. If everything is working, go ahead and press and release the CLR/test button. 3 zeros will appear with 1 arrow that will indicate CPM. At this point, you will also be receiving a background radiation count. When this happens, your meter is ready to use. If anything does not go correctly during the setup process, such as any of these issues listed on the screen, turn the unit off and send it back to the emergency management department for repair. So a few things to keep in mind while setting up your meter. First, in some areas, there may be an unusually low background radiation. This can lead to a count not high enough for your meter to run its test. When this happens, a flashing 0 will appear and say something is wrong, even if the meter is actually working correctly. If a 7 appears before the flashing 7, repeat the test. If a flashing 9 appears after the retest, the meter is working correctly. If the flashing 0 comes back, the meter will need to be repaired. When you are installing or removing the batteries, the probe should always be in the off position, which is the down position. Make sure you always remove the batteries when the meter is not in use. And last, always be careful when using the pancake probe, as the window can easily be damaged. Some other things you will need to know about your 718 involve the control and indicators. Each meter has a dual-purpose trend lights. The trend lights indicate up or down readings, while the alarm is a continuous flashing light that indicates that the rate setting has been reached or exceeded. So most of the time you're going to be using the pancake probe, but there are times that you may need to use the beta gamma probe. This probe has a removable beta shield, so you can easily determine if there is beta or gamma radiation present. When the shield is open, you will be able to detect both beta and gamma, but if the shield is closed, you will only be able to detect gamma radiation. As I said earlier, the pancake probe will be used for most situations. This probe can detect alpha, beta, and gamma radiation. Once you have reached 300 counts per minute or higher, you have reached the level of contamination that calls for decontamination. If anything reads under 300, even if it's at 299, it will be considered clean and safe. On your screen, if a K shows up behind your numbers, you have reached 1,000 counts per minute. So using the example on the screen, the reading is 1,032 counts per minute. Remember, anything over 300 counts per minute is considered contaminated. So if the K shows up, you will have a pretty high level of contamination. Moving on to some of the surveying techniques. When you're setting up your Ludlam monitor, it's a good idea to make sure that you cover the probe in some sort of thin plastic, such as a plastic wrap or a little plastic baggie. This will help protect the probe from becoming contaminated if it accidentally touches a contaminated individual. As I said earlier, it's a good idea to keep the audio in the on position. Being able to hear those clicks will help you know when you're getting closer to a contaminated section. After you perform those operability checks on your monitor, remember to take a background reading before you begin monitoring any individuals. By taking that background reading, you're able to get a baseline of how much radiation is in the background of the area that you're working. So if you have a lot of contaminated people going through your area, then you'll want to check the background again periodically to make sure that the room isn't becoming more contaminated. When you're ready to begin monitoring, make sure that your monitor is set on the most sensitive setting and on the fast mode. That's that FS switch that I mentioned a few slides back. When you're getting close to a contaminated area while monitoring someone, you may want to change it to the slow mode, as well as decrease the sensitivity in order to pinpoint the area and receive an accurate reading. In order to monitor properly, you will need to move the probe no closer than 1 inch, but no further than 3 inches away from the skin. Again, try not to touch the probe to someone's skin. You don't want to get it contaminated. While surveying, you want to go So when surveying, you want to make sure that you're moving the probe no faster than 6 inches per second. For each person you are monitoring, there will be a radiological monitoring form that will be filled out that goes along with them through the whole process. On that form, record all the contamination levels for that person and where the contamination areas are located. Sometimes your probe may become contaminated, If you pull the probe away from someone and the lead continues to beep, that could be a sign that it has some contamination on it. When this happens, you're going to want to swap out the plastic covering that you've placed around it. Also, like I mentioned before, make sure that you're periodically checking the background to ensure that there isn't an increase of contamination in that area. So when you're monitoring someone, you will have them stand in front of you with their arms and legs slightly extended. They should look something like the person in the picture on the screen. You will begin to focus on the head, concentrating on the mouth, nose, and ears to ensure that there's no internal contamination. If those places are contaminated, then they may have internal contamination. Once you have surveyed the head, you're going to slowly move in a zigzag motion over the rest of their body. When you get to the hands, you're going to want to monitor the top of their hands and then ask them to turn their hands over. That way you do not place the probe underneath their hands. When that happens, some particles could fall off the body and fall onto the probe, contaminating it. You're going to then continue to the legs and the top of the feet. When you've completed the front of the body, have them turn around and use that same zigzag motion to monitor the back of their body. When you get to their feet, you're going to want to ask them to lift up each foot so that you can monitor the bottom of their feet. If for some reason that time does not permit you to monitor their entire body, make sure that you're at least checking the head, hands, and feet. More than likely, if those areas are contaminated, the rest of their body may be contaminated as well. The same goes for if they're not contaminated. You may be asked to monitor vehicles for contamination. If so, it's kind of similar to monitoring a person. You will instruct the occupants to roll up their windows and then turn off the ventilation system. At that point, you will want to monitor the front of the vehicle using the same type of zigzag motion. Then move to the side and make sure you're concentrating on areas that the occupants could have touched, such as the door handle, and then the areas of contact on the vehicle that could have contacted the ground, like the wheels. When monitoring the wheel wells, be sure not to touch the probe to the vehicle. Again, you don't want to knock off any particles that could contaminate that probe. Surveying the back and other sides of the vehicles in the same manner. Once you are done, ask the occupants to exit the vehicle and monitor the interior of the vehicle, as well as the engine compartment. You're going to want to focus on the air intake system there. If the vehicle is wet, try to avoid getting any water on your probe, as that water could be contaminated. So there's a chance that you may be asked to survey some equipment as well. Monitoring equipment is the same process as everything else we just discussed. You'll want to make sure that all equipment is removed from the vehicles and then begin using that same zigzag motion to monitor. Again, try not to place the probe underneath anything. If the object cannot be turned over, then just be careful when you're monitoring under the object. When there may be sensitive items, such as weapons, you want to make sure that you're maintaining a chain of custody form that will be sent along with this item through the monitoring and decontamination process. And that concludes our surveying equipment and monitoring module. If you have any questions or have some follow-up concerns, just give me a call at the number listed on the screen.